Hi everyone. So this is the week 7 explanation. So while coming to the group 1, these are all the theory questions what we are having at the starting. Whenever you see in the alpha beta procedure, the presented in the lecture, the alpha and beta are local parameters in each call to alpha beta procedure. And while coming to the second in alpha beta procedure, the evaluation of n of minimum node will lead to pruning when this is regarding the minimum node, we need to write beta is less than or equal to n. Okay, so alpha cuts prunes the childrens of minimum node and beta cuts prunes the childrens of maximum node. Okay, so alpha cuts means childrens of minimum node. Select the correct statement. These are all the so both the alpha beta algorithm and SSS algorithm uh, will change the ordering of the game trees. Both we have need to consider. Not only the alpha beta, SSS are also the same procedure. Okay, but whenever we consider the SSS algorithm, it will prunes at least as many as nodes. Means minimum it will prunes the nodes as like alpha and beta algorithm. Okay. So in SSS procedure, uh, we we are having the two things like when minimum node is solved, meaning that any one minimum node is solved, its parent is solved. But when the last max child is solved, its parent is solved. Meaning that while coming to the minimum, any one minimum is enough to be solved by this parent. And but for max, all the max nodes has to be solved to its be the parent to be solved. Okay, that is we'll see whenever we are solving the solution of SSS. Okay, now if you see the strategies for maximum, so what they ask, which of these procedures construct a game strategy for max? For the max, choose one. If the node is max, choose one. If the node is minimum, then choose all the moves. That is the strategy for the max. And for the minimum, this is opposite. Okay, so for the maximum node, for the max node, we need to choose one move, and for minimum, then choose all the moves. If you see, this is the same highlighted in bold. Okay, which of the game trees depict the strategy for the max? Max means what we told that we need to select for the max node, we need to select one. Okay, so if node is max, choose one. If node is minimum, then choose all the moves. So if the max is one, choose one. Minimum node, so here this box represents the square box represents the maximum node, and this circle represents the minimum node. Okay, now this is the maximum node, choose only one. This is the minimum node, choose all. Okay, again this is maximum, choose one. Okay, so again it is minimum, so you can choose either this one or this one. Anything, normally whenever we are constructing we will choose the leftmost one, but we can choose anything. So here it follows the same strategy. A, so answer is A. If you see B, maximum node selects one, minimum node selects all. Here if you see here, this is the maximum node. Maximum node has to select only one, but here they kept the bold for two, so this is wrong. Okay, now you see for the C also, here this is the maximum node. Okay, and here itself maximum node, it select all three, so C is also wrong. If you see, come to the D, maximum node it selects only one, minimum it selects to two, maximum only one, again minimum all. Here also maximum only one, minimum again two. Okay, so by seeing the diagram we can select which is the strategy for the max, and similarly for minimum, like this. Okay, now while coming to the group 2. Okay, so what they had asked, they had given this one. So we are having the maximum, minimum root is the maximum node, minimum, max, minimum, and we're having a minimax algorithm. And here this W means win, and D means draw, L means loss. Okay, so here they are having the first moves. P, Q, R, S, T are the first two moves we are having our strategies. So what asked is, what is the outcome for the game when both players play perfectly? Okay, when both players play perfectly means the always the maximum node will take the action which is gives the benefit to that one, means which is the maximize maximizer. That is a minimum node, you'll always try to minimize that. Maximizer always tries to maximize that one. Minimizer always tries to minimize this one. So if you see the whenever we are having this like this, we need to come from the backward. So all the last nodes we know the values, will have to come back to the root node from the leaves node. Okay, we will see what is that one. Okay, so this is the thing we are having. If you see here, last all these nodes are maximum. So this is the maximum node. Okay, this is the maximum node, and these are the minimum, and these are the maximum again, and this is the minimum, and these are the maximum nodes. All the leaf nodes, we know the values. Okay, so if you see here, we are not having any value, we need to write here value. It is a minimum node, always it will tries to minimize the value. So if you see the values connected to L, sorry, this minimum node is L and W. Among these two, which is having the minimum means low win. We are having low and win, which is a minimum according to the game, low. So that's why we kept here low. Now consider these two. This is the minimum node. Minimum node always tries to minimize the values. So low. Okay. Now you see this one, D, both D, again D is the value. Now here win, draw. Okay. So minimum is D. Again here L, minimum is L. Here draw L. So minimum is L. Okay. Now we completed all this one. Next go back to the next one. For here, the maximizer. Maximizer always tries to maximize. So what are the things we are having? The win, draw, win. Among these three, win is the maximum. Okay. Next here, low. Okay. Both are low. So we are not having any option. Low is. Next, win, draw, lose. So win is the maximum. So win, draw, win. Win is the maximum. Low. So L. Next, we completed all this. Next, go back to previous. Next, this is the minimum nodes. So W. So we are having a no option. W is the minimum. Win, lose, draw. Lose is the minimum. Win. W. L. L is the minimum. Win, lose. Lose is the minimum. Now we have W. L. So next node is the maximizer. Among this one, which is the maximum? W is the maximum. So we wrote here W. So this way we have to go back from the leaf nodes to the starting root node. Okay. Now we will see the questions what they asked. What is the outcome of the game when both players play perfectly? So when we consider that both players are played correctly, what is the last one? We got the root W we got. So we are writing W. Okay. Which of the moves among PQRST are the best moves for maximum? So for maximum node, always it tries to maximize that one. So maximize means win. So P is having W and R is also having W. So for the maximizer, the best moves, it can take either the P or it can take either R. So we wrote P and R. Next, which of the moves PQRST are best moves for minimum? For minimum, the lowest values. So L, we are having QST. So QST are the best moves for the minimum. Okay. So like this, we need to solve from the leaf nodes to the root node. Whatever the value, sometimes they will give +1, -1 and 0. +1 is for win and the draw is for 0, lose is for -1. Anything it may have. So always consider this as the maximum node. These are the minimum nodes. When both players are playing perfectly, the maximum node always tries to maximize and minimum node always tries to minimize. So whenever you are seeing the minimum at minimum node, consider the children of that node which is having the minimum, that becomes the root, that value of that particular minimum node. Okay. So this is about the group. While coming to the group 3, they had given the same thing, and Minimax, we need to perform the Minimax algorithm for this one. The same procedure we have to follow here also. They had given all the values of the leaf nodes. We'll perform the Minimax algorithm for this one. Okay. Um, okay. So this is the maximum node, and this is the minimum nodes, maximum nodes, and minimum nodes. Okay, so we'll start from the here, this side, A, B. So A is having 32, B is having 84. Among these two, this is the minimum node, minimum is 32. 29, 38, minimum is 29. 82, 54, minimum is 54. 28, 51, 28. 96, 56, 56 is the minimum. 59, 69, 59 is the minimum. 86, 64, 64 is the minimum. 55, 58, 55 is the minimum. Next, maximum nodes. Among 32 and 29, maximum is 32. Next, 54, 28, 54 is the maximum. 56, 59, 59 is the maximum. 64, 55, 64 is the maximum. Next, we are having the next immediate is the minimum. 32, 54. 32 is the minimum. 59, 64. 59 is the minimum. Next, among these two, maximum is the 59. Okay, like this we will go minimum, maximum, minimum. So these are the maximum, boxes are the maximum nodes, circles are the minimum nodes. Okay, so 59 we got. We'll see the questions now. Okay, what is the minimax value of the game? Okay, so after performing the value, we got it as 59 as the root value. So 59 is the value. Okay, list the horizon nodes in the best strategy for the max. So whenever we have to write the horizon nodes, what we need to do is to take the same thing. Okay, um, we got here the 59 value. Okay, wait, this we will see this one only. Okay, so we got this 59 is the, whenever we want to write the horizon nodes, you see this value 59. So where this 59 comes from, this value, where this 59 comes from, here, where this 59 comes from, here. So what are the nodes connected to these values? K, L. Okay, so K, L are horizon nodes. Again you see this 59. So selecting this 59 at this minimum node will be affected by this 64. So if assume that if we are having less than 59, if we are having in place of 64, if we are having a value which is less than 59, this minimum node will select this value instead of 59 because this value is less than 59. But now uh, this is having 64, that's why it's not selected 64 and selected 69. So there may be chances of comparing this particular node also. So this 59 comparing these two. Okay, so 59, 64, where the 64 comes from, here. So M, N. So K, L, M, N are the horizon nodes. Okay, so 59 we are having the value. So see, go back where we got this 59. From here we got 59. This 59 we got from these two. So this 59 and the 64 comparing, which is the minimum, and we wrote 59. That's why consider these two. And this 59 comes from here. So K, L, because this value is also affected for this 59. Okay, if we are not considering this value, then if we are having less than value, then we may get the another value. Okay, that's why we need to consider this 59 is compared between these two nodes. So KL, and this 64 we got comparing these two. So MN. So KLMN are the horizon nodes. Okay, so the horizon nodes in the best strategy for the max is KLMN. Now, change the evaluation of exactly one horizon node to get a new minimax value of 55. Okay. So, if you want to get here 55, okay, uh, if you want to get here 55, which node you need to change? Okay, here if they are required, here it is a 55. Which node we need to change? Okay, so if I want 55, this is the 55. Okay, so if I want 55 has to be the maximum here, then what is the thing I need to reduce? Here I need to reduce this 64. Okay, this 64 has to be reduced. Assume that if it is less than 55, assume that it is instead of 64, assume that this is 46. Then this is 46 because the minimum value 46. Among these two, now 46 and 55. So which is the maximum? 55. Okay, then 55, 59 and 55, minimum is 55. Then among 32 and 55, maximum is 55. So if you are having a chance of changing only one node, then they ask you to get the 55 at the root node, which node you have to be changed. So you have to trace like this, where we are having 55, go back to that node, this 55. If I want to get 55, then this 64 has to be replaced with the 55. So I should not get 64, I have to get 55, meaning that the 60, whatever the value at this particular place has to be less than 55. Okay, so then what is the node connected to the 64? N is the node connected to that particular. If I change the node N, if it is less than 55, then minimum among these two, then maximum this at this particular place the maximum node selects 55, and then this 55 will go back to the root node. So the node which has to be changed is the N. Okay, N is the node. Next, change the evaluation of one horizon node to get a new minimax value as 64. Now they ask you to change only one value to get the value as 64. Follow the same procedure where we are having the 64. Okay, this is the 64 we are having at this place, particular place. Okay, so if I want to get here 64, okay, so this is the maximizer. Okay, here also 64. Okay, no problem here, no need to consider 64. Okay, so at this particular place I need to get the 64. I need to get 64 here. Here also 64 I get. If I want to get 64 here, okay, so minimum, meaning that this particular node should be greater than 64. Then only this minimum node select this 64. It should be less than 64. This 59 value has to be changed. So this 59, okay, 59, and it has to, this 59 comes from both K and L. But if you see, this is the minimum node, that's why it's selected from here, 59. So this K value has to be changed. If I change the K value, assume that if I change the K value to some 95, okay, assume that if it is 95 greater than 64, okay, so this is the minimum, uh, then it is 69, no, then it becomes minimum value, it is 69, um, 69, so maximum here it is get the 69. Okay, here it will get the 69. Among these two, maximum again I will get the 69. Among these two, minimum 64. The 64 will goes here. So only one node I should change here is K. Okay, I have to change the this K value. So the value has to be changed is the K. So like that you need to go and check the nodes which has. So sometimes we may write the J also. So if you see this 56, we may change this 56 to get the higher value here, the maximizer. If I get instead of 56 here, if I write another value, the minimum value here, assume that if I are having the 65 here, so here I will get the 65. Maximum among 59 and 65, 65 here. Among 65 and 64, minimum is 64. Like that I will. So I can change either J or A. Both answers are correct here. Okay. So that's why the J is also accepted answer here. Here also like the same procedure. M is also correct answer. Here M and both here. You can change either M or N. Okay. Now list out the horizontal nodes proved by the alpha cuts. Now our main goal is the what is meant by alpha cut and what is meant by beta cut. Okay. Now see, this is the maximum node and these are called the, all the alpha nodes are called the maximum nodes, all the minimum nodes are called the beta nodes. Okay. So whenever we see that one, in the theory question also we saw one question uh, regarding the alpha cuts. Okay. So alpha cuts proves the children's of minimum node, beta cuts proves the children's of maximum node. Okay. So if I see here, if I proves like this, um, these things. Okay. So this is the minimum node. I am pruning this. Pruning means no need to visit that particular node. Okay, whenever we are seeing that minimax algorithm, we will see these. If I don't want to visit this particular node, meaning that I am removing this children's of minimum node. So this is called the alpha cut. If I see this is the maximum node. If I prune from here onwards, this, if I cut this one, this is called the beta cutoff, and this is called the alpha cutoff. Alpha cutoff means it will prune the children's of minimum node. Beta cutoff means that these are called the beta cutoff, proves the children's of maximum node, and these are called the alpha cutoff, proves the children's of minimum node. Okay, you need to remember that. Now, what we asked is the same diagram we are using everywhere, and first we are has list out the horizontal nodes proved by the alpha cuts. Okay, so whenever we are having like that, what we need to do is see, this is the given thing. In order to look, means that looking purpose, I cut this left part and right part separately. Okay, this is the, so whenever we are doing alpha beta cutoff, what we need to do is um, always the alpha is the we need, so this is the procedure I am writing here, alpha and, okay, so alpha and beta values, alpha comma beta values, always the alpha starts with the minus infinity and beta starts with the plus infinity. Okay, max alpha node, this is the max node, beta is the value at the minimum node. Okay, so maximum value minus alpha, that is minus infinity, beta is the plus infinity. Alpha values minus infinity and beta values plus infinity. The same procedure will move here, minus infinity, plus infinity, sorry, infinity, minus infinity, plus infinity, here minus infinity, plus infinity. Okay, now at this particular node, we will see, first it will visit this particular node 32. Okay, so 32 we are having alpha value as minus infinity, beta value as the plus infinity. Minimum node, you remember, you mind, minimum node we need to change the beta value. At the maximum node we need to change the alpha value. Okay, now this is the minimum node, we need to change the beta value. Beta is the second value, alpha beta value. So 32. Okay, so change that one to beta is the minimum. 32 is less than plus infinity. So we got minus infinity 32. Next, it will visit this next sibling, that is 84. Okay, so when comparing this 84 with 32, 32 is minimum. So leave as it is. So now we are having alpha minus infinity, beta is 32. So the same thing will move to the whatever the value. Now here we got the 32 value. That value will be moved to the immediate max node. Whenever we are transferring max node, the alpha value will be updated. What is the alpha value? Minus infinity. Now it becomes as 32 and infinity. 32 and infinity. The same value will pass here. Whenever we are updating the minimum node, beta value will be updated, and the maximum node also will be updated. And that is when you are backtracking. Now 32 infinity. Now first visit the C node, that is 29. 29. Okay. So minimum node beta value has to be updated. So 32. Now beta value becomes 29. Now you see here alpha is greater than beta. Whenever we get a condition like alpha is greater than or equal to beta, then at the minimum node, here this condition alpha is greater than or equal to beta occurs at the minimum node. Okay, so this is called the alpha cutoff. Alpha cutoff. No need to go and visit this particular node. Okay, so whenever alpha cutoff occurs, then the alpha value will be returned to this maximum. Alpha value will be returned to the immediate. So maximum node, alpha will be updated. So already it is 32 infinity. The same thing will be moved here, and here this is the minimum node, and the minimum node the beta value will be updated. So minus infinity. Now we got here 32. So minus infinity and 32. Now here. Okay. Now again this minus infinity 32 minus infinity and 32. And now at this minimum node first it will visit 82. Okay. And 82 is received by this minimum node, all updating this beta. Minimum value means beta value. That 32 is already we are having. 32 is less than 82, so no need to update that value. Keep as it is 32. Next again 54. 54 is also greater than the 32, so keep this value as it is 32. So minus infinity 32 as it is. Now move to here 32 value. Here we got only 32 only. This 32 value will be forwarded to the maximum node. At the maximum node, the alpha value will be changed. Now it becomes 32, 32. Here alpha is greater than or equal to beta condition satisfied. Okay, so no need to visit the remaining nodes. So this cutoff, this condition happens at the maximum node. So this is called the beta cutoff. At max, it occurs at maximum node. Previously, it occurs at the minimum node. That's why you call it as alpha cutoff. Here we got it at the maximum node. That's why we get it as beta cutoff. So this beta value will be moved to here. So this 32 will be backward to here, beta value. Okay, this beta value 32. So here the minimum node, minimum has to be changed. Already we are having the minimum 32 minus infinity 32. This 32 will be forwarded to here. This is the maximum node. So alpha value has to be changed 32 comma infinity. Okay, this is at the left side part. We got 32 infinity. Okay, now we'll see the next this side part. Okay, we got 32 and infinity. Okay, here we got 32 infinity, 32 infinity, 32 infinity. Minimum node first 96. Okay, so 96 is less than infinity, so it will update 32 96. Next it will visit 56. 56 is minimum than 96, so it will update it as 32 and 56. Okay, now it move to here, that 56 value we got here, the 56, it will move here. Here this is the maximum node, alpha value has to be updated, so alpha value now becomes it as 56 and infinity. So again it will move the next siblings 56 infinity. Now minimum 59, so 59, here we are having infinity, so this is less than 56, 59. Next it will move to the next 69. 69 is higher than 59, so leaving we are having 56 and we are not having any alpha is greater than or equal to beta condition. So 56 and 59, alpha is less than beta. So this 59 value will go back to here. So we will update that alpha value here because it is a maximum node. Okay, so we will get 59 and infinity. Okay, now this 59 value will be forwarded to here. This is the minimum node, so the beta value has to be updated 32 and 59. Okay, now 32 and 59, 32 comma 59. So 86 will be received here. 86 is maximum compared to 59, so keep as it is 59. 64 and 59. So 59 is less, so 59 keep as it is. Now here 59 as it is. Now given back to maximum node. At the maximum node, alpha has to be changed. So instead of 32, we have to write 59 and 15. Now alpha is greater than or equal to beta. This equal condition satisfied. So no need to visit these nodes. So this cutoff alpha greater than or equal to beta cutoff occurs at maximum node. So these are called beta cutoffs. Beta cutoffs. So return the beta value. Beta value means 59. Okay, this 59. This is the minimum node. So minimum is 59. Given back to here. This is the maximum node. Alpha has to be changed. So 59 comma 59. So now 59 value. So we got the 59 as the value of the root node. So if you remember previously also we got here 59. Okay. This is the procedure as the alpha beta cutoffs. Now we will see the questions what they asked us to calculate. List the horizontal nodes pruned by the first alpha cutoffs. Alpha cutoffs here. First here we got alpha cutoff here. So what are the nodes? Pruned means whenever we get here alpha cutoff, no need to see what is the value at this particular node D. Okay, so then node is called the beta. So meaning that even though it is whether it is maybe less than this 29 or greater than 29, it won't affect the root value. That is the meaning. No need to visit again and see what is the value. Whether it may be 29 less than or 29 greater, it won't affect that particular value. Okay, so only we're having alpha cutoff is only at a D. Okay, so we're having alpha cutoff only at a D. Beta cutoff, here we got one ZH, here we got OP. Okay, GH, OP are the beta cutoffs. Okay, now we will stop and we will see the next